Hey there, Econ. It's Mr. McCown. Today I'm going to talk to you about the 2008 AP Macro FRQ question number 3. Many of my students find this one to be one of the most difficult FRQs that they encounter the entire year, let alone in our first unit, Basic Concepts. Right now I'm going to ask you to pause the video and read the question in its entirety. While you're reading, I want you to think about how you would organize your answer, and if you were taking this test, what parts of this question would you mark up so that you're sure not to miss? Part A asks you to calculate opportunity cost. Part B talks about specialization in trade and wants to know which country would import bicycles. Make sure that you take note of the word explain here. If you don't explain, you're going to miss a point. Part C, what is the most difficult, and I'll be spending the most of my time on this video, deals with terms of trade. This one's particularly difficult because it asks you if the terms of trade were a certain amount, 5 hats for one bicycle, would trade be advantageous for country A? What about for country B? And then finally in part D, if productivity in Artland triples, which country has the comparative advantage in the production of hats? Now that we've had a chance to read the prompt, what we're going to do next is show you how I've organized my thoughts so I can come up with the answer. What I've done up here is I've created this grid where I compare hat production to bike production and Artland's ability to produce to Raylan's ability to produce. I've transferred the numbers from the grid, or from the production possibilities frontier, onto this grid. Now the way that I did this, there is one minor step that's kind of important, and that's that I've put these numbers offset to the left and in the center of my space. I've given myself space above and below and to the right of each number. That's going to be important as I go through this process. This is an output method question, so we're going to be using the acronym OOA+. Output, the other goes over, and when we're looking at absolute advantage, we're looking for the largest number. Were it to be an input method question, it would be input, other goes under, absolute advantage is going to be the smallest inputs required to produce, like time usually. So, output method question, the other is going to go over when I'm looking for comparative advantage. Comparative advantage is defined as the lowest per unit opportunity cost. So, who's got a lower per unit opportunity cost in hat production versus who has a lower per unit opportunity cost in bike production? To get that, we have to figure out what each country's opportunity cost is. That's where the other goes over. So we're going to find the opportunity cost for hats, we're going to take bike production and put it over hat production. So the 300 is going to go over the 600. 3 over 6 is 1/2. So what this tells us now is that when Artland goes to make one hat, they could have made a half of a bicycle. So we're going to write it out just like that. Eliminate any chance of mental errors. So 1 hat in Artland equals 1/2 of a bike. Now, when we come over here, the 6 over the 3, or 600 over 300, is going to turn into 2. So 1 bike in this case is going to equal 2 hats. We're going to do the same thing down here with Rayland. Other goes over. 1 hat is going to equal 1/4 of a bike. And the other goes over. 1 bike is going to equal 4 hats. Notice that 1/2 and 2 are reciprocals, and so is 1/4 and 4. It should always be that way when you're looking at opportunity cost of producing one thing versus the other. It's always going to just kind of flip-flop like that. Next thing I'm going to do is I'm going to figure out, now that I've figured out opportunity cost, I'm looking for comparative advantage. Comparative advantage is always the smallest opportunity cost, so we're looking for the smallest number, whether that's an output or an input method question. So when I'm comparing hats in Artland to hats in Rayland, which number is smaller, 1/2 or 1/4 of a bike? 1/4 of a bike is the smaller opportunity cost. Rayland, when they produce 1 hat, they only have to give up 1/4 of a bike, which is more efficient than Artland's 1/2 of a bike. Same thing over here for bikes. What's a smaller number? 2 is a smaller number than 4. Now, just like this is going to be reciprocal of this, you're going to see It's going to go across the corner. It's mathematically impossible for one country to have comparative advantage in both things. So once you've figured out one, you've also figured out the other. So it's a good, easy way to check your work there. Now that we know comparative advantage, what we need to do next is figure out the really hard part, which is terms of trade. Terms of trade that are offered on the question are 5 hats for 1 bike. Would this be acceptable for each country? Would it be acceptable for Artland? And what about Rayland? Show you a couple different ways to figure this one out. So one way we could figure this out is we're going to look at our grid. And 5 hats for 1 bike, well, let's look at the production of 1 bike. When we go to make 1 bike, we give up 2 hats in Artland. When we go to make 1 bike, we give up 4 hats in Rayland. So we're going to look right here. So all we want to do is for this 1 to what ratio would be acceptable? Find something between 2 and 4. If the number of hats was below 2 hats, it would not be acceptable to Artland. If the number of hats was above 4 hats, it would not be acceptable to Rayland. So in this example, it is not acceptable to Rayland. So what we see here is that Artland would accept these terms of trade of 5 hats for 1 bike, and Rayland would not, because they would lose a bike by accepting these terms of trade. Now let's look at it a second way. If we were to write it out below the grid again, it might make it more clear for some of us to see, to understand. So let's go ahead and do that. Artland, right now, what are they producing? Artland is producing bikes. When Artland makes 1 bike, they are producing it for an opportunity cost of 2 hats, and they're making the bike. Now, Rayland, they're going to make the hats, and so when they make 1 hat, they are producing for an opportunity cost of 1/4 of a bike. Now, what we have to do is put this information into the same terms as this. It's like an algebraic equation. So we need to get the 1 bike to 1 bike. We've got that. And over here we need 5 hats to 5 hats. So we're just going to multiply this by 5. So this is going to become 5 hats, and 1/4 multiplied by 5 is going to become, well, I don't need to erase that, 1 1/4 hats, 1.25 hats. Now, if Artland is making the bike, they could have 2 hats if they were to produce the hats themselves instead, or they could have 5 hats. They would rather have 5 hats. They would accept these terms of trade once again. Rayland, on the other hand, is going to make 5 hats, and for every 5 hats that they make, they could have instead made 1 1/4 bikes, or by trading, they could get only 1/4 of a bike. They would not accept these terms of trade. They would rather produce themselves. Okay. There's a third way to look at that, and that is to look at the slope of the line. I'll show you that right now. So, using the same method as before, the output other goes over method, I am first going to look at the production possibilities for Rayland. So I'm going to put the 12 over the 300, and that's going to give me an opportunity cost of 4. And just like our grid before, we had 1 bike for Rayland equals 4 hats. So it's 1 bike for Rayland equals 4 hats, much the same as we did in the grid. Over here it's going to be the reciprocal of that, so it's going to be 1/4 of a hat is going to be equal to 4 bikes. So 1/4 of a bike. 1/4 of a hat. 1 hat is equal to 1/4 of a bike, excuse me. Now with Artland, do the exact same. So this is going to be a 1/2 of a bike, and this is going to be 2 hats for Artland. Now we figured out on the grid before, it's a little easier to figure out comparative advantage for me anyway that way. On the grid we figured out that Artland has the comparative advantage in bike production and at an opportunity cost of only 2 hats, and so they will be producing here. Rayland, put an A for Artland, Rayland will be producing the hats at an opportunity cost of 1/4 of a bike. So I'll put an R for Rayland's point of production right there. So that's going to be how their points of allocative efficiency shift as they decide to trade, specialize in trade. Now on this graph with the slopes, what we've just done, imagine these slopes as we're comparing one bike to how many hats. So let's start here, and let's imagine like this would be a slope of 1, this is a slope of 2, a slope of 3, a slope of 4, and a slope of 5 would be right there. So that's going to be the opportunity cost that, or the terms of trade that was asked about in the prompt. So that is beyond what is acceptable for Rayland. Artland would love it. And in between, anywhere between this slope of 2 and the slope of 4 would be something that would be acceptable for both countries. To further illustrate this concept, I've created a production possibilities table out of the graph. You notice over here in Artland that every time I gain 50 bikes in production, that's at an opportunity cost of 100 hats per the underlined data points. That is a 1 bike to 2 hat ratio, just like when we figured out the per unit opportunity cost. Now here in Rayland, we see our 1 hat to 1 quarter bike ratio, where every 25 bikes that we gain, we lose the production of 100 hats. Same ratio as above. You'll notice that if we traded 1 bike for 3 hats, which would be acceptable terms of trade between these two countries, that with this same ratio, if Artland were to export 100 of their bikes in exchange for 300 hats from Rayland, Artland would now consume 300 hats and 200 bikes, while Rayland would be consuming 900 hats and 100 bikes, as illustrated on the chart here. Each country would now be consuming beyond their production possibilities, which you can see by matching these numbers up to our production possibilities table for each country independently. Okay, now on to part D. If productivity in Artland triples, which country has the comparative advantage in hat production? Here at the top, you see that Artland could produce 600 hats or 300 bikes, and we have the per unit opportunity cost broken down here, just like earlier in the video. And then at the bottom, I've tripled the production of hats and tripled the production of bikes, and you'll notice when we do the math, the other goes over. The ratio is still the same. 1 hat still costs half of a bike, just as it did above, and 1 bike still costs 2 hats in Artland, just as it did above. So the ratio stays the same, the comparative advantage stays the same. Now that I've walked you through each step, go ahead and pause the video and see if you can complete this entire FRQ yourself. Here's the rubric. Check your work and see how you did. I hope this video helped you out. Thanks for watching.